All right, greetings, all you Vaughnables. And for those who don't know what that means all the people taking this Vaughn and Mr. Alba's class. So you are now Vaughnables. Today we are going to talk about how to graph absolute value functions. You actually have graphed them on the Chapter 4 test. You had an absolute value function that you had to graph. And the only way we did it at that time was when we actually plotted points. But I promised you there'd be an easier way to do it. And so here is an easier way to actually go through and plot an absolute value function on a graph. So the very first function, we're going to start off with one that's not too tricky. The absolute value function that you can see is y equals -3 times the absolute value of x minus 4 minus 2. And there's actually a system to go through to solve this. And the first thing I'm going to do is I'm going to try and find out the vertex point. Because remember, all absolute value functions have a v-type look to it. So there's got to either be a lowest point would be the minimum point, or the highest point, which would be the maximum point. So here what I'm going to do is I'm going to try and find the vertex. And the vertex is found when this takes place. When this value here is the smallest or the largest it can possibly be, that's the point where your vertex is going to be. So when I do this, I'm going to actually come off to the right here, and the smallest that it can be, wait a second, I need to put it down and pick it up again. So when x minus 4, the smallest that value can be inside the absolute value is 0. So x is going to have to be greater than or equal to x minus 4 is greater than or equal to 0. When I solve, I get x equals 4, actually greater than or equal to 4. But really, all I care about is the smallest point. So what I really care about here is x equals 4. So my vertex point is going to be at the ordered pair 4 comma something. All right. Well, what is that something going to be? So the way I find it is I plug it right back into my equation. So I have y equals -3 times the absolute value of 4 minus 4 minus 2. And if I work that out, well, wait a second, 4 minus 4, that's 0. And I end up having -3 times the absolute value of 0, which is 0, which minus 2. Well, that's just -2, because -3 times 0 is 0, minus 2 is -2. So my vertex point is -2. And those of you might have noticed that that point for the y portion of the vertex is just whatever is hanging off on the end there. So the -2 comes right there. All right, so I've got my vertex point. I'm going to plot it over on my grid. So 4 comma -2, that's where my vertex point is going to be. Now the axis of symmetry, since it's a v and it's a function, my axis of symmetry is actually going to be the vertical line that runs through that vertex. And we've learned already that all vertical lines must have the equation x equals, and in this case, every point on that line is x equals 4. So now I have my axis of symmetry equation of x equals 4. Now, what we can do next, I'm going to show you two ways. I'm going to go through and show you how to plot first and then calculate second if necessary. And then later on, I'll show you how you actually can do the calculation of the x and the y-intercept. So anyway, so we're looking at this right here, and we notice that, well, we've got a point here at 4 comma -2, and we've got to figure out whether our v is going to go up or it's going to go down. So for right now, I'll just tell you right now that you can tell immediately, and I'll explain why a little later on, but you can tell immediately that it's going to go down because there's a negative out in front of that thing. And that's kind of like the slope. If you think back on the slope in y equals mx plus b, that's like the slope. So if you see that negative out in front, every single time it's going to go down. And the slope that we're going to be using here is, it looks like we're just going to use -3, but actually, there's a little 1 in front of the x. We have to multiply -3 times that 1. And so the slope we're going to use to graph our equation is going to be -3 times 1, which equals -3. And you might think, well, then, okay, my slope is -3, and you're partially right. So if I want to find my slope, find the rest of my graph, I go down 1, 2, 3 to the right 1, down 1, 2, 3 to the right 1, down 1, 2, and it's going to go off the graph at that point. And if I connect it, what I end up having at this particular time is half of my v. All right, you're wondering, well, where's the other half going to be? Well, that's where the axis of symmetry comes in, where everything is going to be reflected over that axis of symmetry, which is x equals 4. So you notice how we went down 1, 2, 3 to the right 1? To find the rest of the v, you're going to go down 1, 2, 3 to the left 1. and plot a point. Then down 1, 2, 3 to the left one, and so forth. And so when I graph the rest of it, there is my v, and that's going to be the graph of that particular equation. All right, so now you're saying, well, what do I need to know for x and y intercepts? Because if you look at the x-intercept, there is no x-intercept, so I must be done. And you'd be right, there is no x-intercept. So the x-intercept for this particular problem is no solution. But how would you go about graphing it, or actually calculating it algebraically if you had to? Well, the way that I would do this, if you remember, if I take the equation, remember the original equation, y equals -3 times the quantity x minus 4 minus 2, you'll recall that at an x-intercept, the y value is 0. So I can go back to my equation and put 0 in for y, and I can solve for x. You're wondering why we had to learn all that absolute value stuff, that nonsense early in the year. This is why. So now if I solve this, I'm going to add 2 to both sides. So I'll have 2 equals -3 times the absolute value of x minus 4. Divide both sides by -3. And I'm left with the absolute value of x minus 4 is equal to -2/3. And if you recall, absolute values can never equal a negative number, so therefore it must be no solution, as I'd stated before. So that would be the x-intercept. In that case, you're going to solve the absolute value equation, and then you're going to get your values for the x-intercept. In this case, there's no solution. Now the y-intercept, if you can go ahead and plot it, go for it, and that's great. But in this case, you'll notice the y-intercept is actually going to be off the graph somewhere. You might be able to figure it out, but sometimes you can't figure it out for 2 reasons. One, it's too far off the graph. Or 2, the other reason you might not be able to figure it out is because it might be like, let's say the y-intercept is going to be -9 3/8. Do you really think you could be exactly and get the exact y-intercept without an algebraic solution? Highly unlikely. So we're going to go through, and actually the y-intercept's a lot easier to calculate than the x-intercept, because in this case it's just the x value that is going to be equal to 0. So when I do this, I'll go back to my original equation, and I will put in y equals -3 times the absolute value, but this time I'm going to put 0 in for x, minus 4 minus 2. If I solve that, I get -3 times the absolute, so it's going to be -4 minus 2, so that's -3 times 4 minus 2, which becomes -12 minus 2, so the y-intercept is at -14. So the ordered pair would be 0, -14. So if I want to find the y-intercept, you have to write it as an ordered pair, 0, -14. And it kind of makes sense. If I were to continue down on my particular graph, and I were to go down 1, 2, 3 more and over 1, that's that -11, 1, 2, 3 over 1 more, that would be at -14. And that does make sense. All right. So that's how you would actually solve that algebraically. Now, as far as the domain and range goes, domain is, I'll give you a hint on it, domain is actually very, very easy in these types of problems, because the domain, I'd say almost all the time in what we're dealing with, is going to go from -infinity to +infinity. So we just say the domain is all possible real numbers. So the domain is always going to be easy for you. The range, though, is going to be a little bit trickier. So in this case, we're going to look at the range and say, all right, we're starting at -2 and we're going down. So the range is going to be all values of y that are less than or equal to -2. And that is how you would go about finding and graphing your solution without actually plotting lots and lots of points. Notice that we first found the vertex. Once we found the vertex, we went ahead and used the slope to plot points down in one direction. Then we did the axis symmetry, and we found the reflection over to the other side of the axis symmetry and found the rest of the points. And then we solved algebraically for the x-intercept and for the y-intercept. And then the domain and range we came from just from the graph. So I'm going to stop this right now at 9 minutes. And then I'm going to start up another video, because if I go beyond 15 minutes, I will not be able to put it into my account for right now. So that's your first one. We're going to have one more that you're going to look at, and the second one won't take as long. Thank you.